Chapter 15, Trematoda, Form and Function. Part 5, Nervous System. Now this is something that we need to get our minds around. Not only do these flukes have a muscular system, different individual muscles, that can control movements, remember different ways and things like that, but they also have rudimentary nervous systems. Now, these are not a nervous system like we have, the central nervous system, the peripheral nervous system. No. They have nerves, they have sensory organs of a sort, and they will have some form of a nerve ganglia, where the nerves, the different nerves come together and there'll be a cluster. It allows for crosstalk between the different, the nerve bundles, and allow for reaction to external stimuli. But it, under no conditions and in no way are you to even think that this is a brain. When we look at stained samples of these trematodes, the flukes, we see that there is a generalized setup for the nerves. They call it ladder-like. You have the oval shape. You will have longitudinal running along the edge, one set of nerves, one other set of nerves here, and then there's going to be transverse rings that, go from one side to the other, hence ladder-like. When you look here at this generalized picture, you see that there are, from anterior to posterior tip along the periphery, where we go, and they start at the anterior end, go to the posterior end, they run along the periphery, the edge. And then there's going to be these circular, from one side to the other, transverse, acting as a ladder. Now, there are going to be sensory endings. There are going to be sensory mechanisms. As you see here from our friend Fasciola hepatica, some of these flukes are going to have eye spots, especially during their larval and juvenile, stages where they are free swimming. They have to be able to orient themselves as they are swimming. And by having eye spots doesn't mean they can see. It means that they can, their nerves can detect sunlight. So it allows them to orient eye spots, sun above. Because without those eye spots, how would they orient and how would they be able to sit there and react to stimuli and be able to swim up a concentration gradient? There's also going to be what they refer to as tango receptors. Okay? Tango receptors basically are a version of touch receptors. Tango receptors are going to be there, I do believe, through larval, juvenile, as well as adult, because remember, they got to be able to sit there and touch and feel and be able to swim up through tissues and things like that. But the eye spot from the previous slide, and there's also going to be one nerve endings that say gravity, help with, orienting, due to the gravitational, pull, so they can orient themselves and know which way's up, which way's down. It's going to be lacking in the adults. Once they're inside the definitive host, they really don't need to know, whether or not there's sunlight. And what we found is there's quite a lot of neurotransmitter and neuropeptide work going on here. How we sit there and we study a lot of our neurotransmitters and our neuropeptides. If you want to sit there and study how acetylcholine, can take the nerve impulse from neuron 1, dumped in the synapse, and then you see the kickoff in neuron 2. Hard to do that can't do that in a human. Hard to do that in neural tissue that you're, cultivating or culturing in a petri dish. But oh my gosh, if you got something as simple as a trematode, a fluke, let's study it. Let's see what happens when you overproduce acetylcholine, underproduce acetylcholine. You don't have acetylcholine. You have antagonists to acetylcholine. And the neuropeptides, these are going to be other messengers that can be used by neurons to sit there and crosstalk to each other, in a nerve ganglia or across a synapse. What happens if we mutate them? What happens if we change them, overproduce, underproduce? Have some sort of an agonist or some sort of protagonistic effect of other chemicals that may be there. Again, can't study this in full animals like us. Too much going on. It's a little hard to do in a petri dish because you really can't control, which neurons are going to be acting with other neurons, and you can't always control how they're going to grow and are they going to be close enough to form a synapse. But hey, a fluke, that's something I can work with.